Oh, hi today. Just wondered if you might have any idea about something that, because you have a mathematical brain, you might be able to think your way around this a bit more. Plus it relates to something you said the other day. You said the other day in one of your videos, and I'm not challenging it, I'm just linking this in. You had your little wavy wire to represent, electromagnetic wave, or one aspect of it, the B field or the E field, whatever. And you were trying to explain that this isn't meant to be taken literally, that there isn't an actual physical dimension, the electric field isn't this wide, or magnetic field isn't that wide, and so it doesn't have a physical dimension in the literal sense of the word. Yeah, I get that. But it does still make me wonder, pardon me. Yeah, so you're saying it's not unaccepted that the electromagnetic wave, if it is a wave, whatever, hasn't got a physical dimension in the way that we tend to think of it, because of the drawings that are meant to are just illustrative, really. They're to help us to just get a handle on things. But my question though is, and it's not a challenge, it's just hoping you might be able to explain, how come the waveguide, in the case of this WR90 type stuff, I know waveguide comes in different shapes, but common form is this rectangular stuff, which is always that same ratio of width to length, or width to breadth, whichever. Anyway, and that relates to the wave length, right? And I read an explanation yesterday when I googled about this. I think the wavelength has to be able to fit into that longer dimension. So this, if it can't fit into that dimension, apparently the wave can't propagate. Now, obviously, I have issues with the wave theory anyway, but we'll come to that another time. Just assuming the wave theory was correct, though, just for argument's sake. Supposing I didn't have any issues with that, and I didn't believe in it being particles, etc. I struggle to understand why the width, if it doesn't have a physical dimension, left and right or up down, why is the width that way or the height that way relevant? Why does it have to? Well, you see where I'm going with this. Why can it not propagate through if the wavelength is longer than that? Now you see, if you Google it, there are absolutely there are dozens of different WR sizes, waveguide sizes. So Draft Science was arguing against my last experiment, saying it was invalid because I'd used WR90 to try and detect not just 10 gigahertz, but anything up to, what was it? What was the frequency doubled? I'm trying to remember what it was. I think it was 8.3, so it was 16.6. 16.6, and his argument would be that 16.6 wouldn't be favoured by this size. But if you actually look at the table of WR90 and so on, the ideal size would have been WR51 in his case. That would be an average. But there are one or two other WR49, I forget the terms now, there's quite a few that would have also favoured 16.6 gigahertz or thereabouts. And the reality is, because the chart tells you, this is the recommended frequency range, 8 point this to 12 point that, for WR90, but it will actually go down quite comfortably down to 6 point this and 13, 14 point that, whatever, I forget now. And quite obviously, it's following what I'm saying is, quite obviously, like if there was 16.6 gigahertz there, I'm quite sure it would have found it, and that really all I need to do is just change the width and the height a little bit, and hey presto, we've now got WR51, and that should be favouring the frequency Draft Science is looking for. And I'm 100% certain it still won't find it, because regardless of whether I'm using WR51 or W90, it just, what he's looking for isn't there. Well, I can comfortably say that because I've just done his other experiment where where he thinks he's going to find it, you know, between standing waves between two horns being fed with a common source, and surprise, surprise, doesn't work, does it? You know what I mean? Yeah, the pattern's there, you know, where they're using sound on an actual normal diode detector, which he's not happy with, even though that is showing you the voltage that he's looking for. I think he's not happy with it because it's not showing the voltage he wants to find. The voltage we actually are getting he's not happy with, because at the end of the day, it's no matter what he says. Where's the thing gone? Where's the point meters? But at the end of the day, it is voltage operating that meter. It might say current on it, but that's only. It doesn't literally mean that it can't be pushing current through that unless it's got an applied voltage. So the diode is rectifying the AC, and oh, and again, like they say, oh, but the diode is frequency dependent. Well, up to a point, that's true, but again, it doesn't just suddenly cut off at 12 gigahertz. You know, it's going to trail off, get less and less. You know, it might be a fairly steep drop off, but you should be able to find something. But then I've tried his method, his suggested method, where he says, well, put a detector, a nail or something like that. It uses a little antenna and just detect pure voltage, whatever pure voltage is. There's not really such a thing as such, is it? He thinks using your best voltmeter anyway. So I've done that using my best voltmeter, and surprise, surprise, it picks up fuck all, no matter where you put it. Why? Because even your best voltmeter isn't designed to collect RF frequency. You put it on the AC setting, and it's meant. How does he think the AC setting on a voltmeter actually works? It effectively rectifies it's going to rectify the voltage it's detecting in order to come to a conclusion what AC voltage that is. It's not going to. Well, plus the speed of the rectifier used is relevant, because some of them work up to 24 gigahertz, but not the ones in voltmeters. Not you. Yeah, I think. See, what it smacks of for me is that he just doesn't want to accept the results or the common sense of the situation. I mean, see, if you just apply common sense logic to the theory, by rights, if his theory was correct, then we should see ultraviolet light when we do, at the minima, when we do the double slit experiment with, say, 400 terahertz red light. At the minima, that should double to 800 terahertz, and we'd see, you know, ultraviolet light there. And then in between there, because he says all the other frequencies would be all sorts of frequencies that the detector can't pick up because it's tuned to this and it's tuned to that, but light isn't. We should be able to see with our eyes all those our eyes are perfect detectors, aren't they, of all those different frequencies between 400 and 800. Well, almost all. Can't get. Our eyes are perfect for detecting most of those frequencies anyway, aren't they? You know, from red 400 terahertz to blue 700 terahertz. It's only to the last 100 terahertz into the infrared, no, into the ultraviolet that our eyes fail. So by rights, we ought to be able to see that effect if it was true. We don't need voltage detectors. We don't need, thinking about it, you know, to boil water and, you know, row of test tubes. Although that would have been interesting, but. And I did do some work on using the magnetron the other day, by the way. That's by the way. Because I thought, if you want to fucking use eye power. If you want fucking eye power, I'll give you eye power. But anyway, pardon me. So, yeah, so our eyes are perfect detectors. We should be able to see that, oh, it starts off red where it's maximum, but then it goes to, all sorts of colours, or white light, because it's such a mixture of colours, surely, you know. Why doesn't it change? You know, because of the mixture of frequencies that he insists must be present between the transition from perfectly on phase to perfectly out of phase. Why does he think that 2 out of phase sound waves make double the frequency, when any audio engineer knows that that isn't the case, that they simply cancel one out? I could show him on these sodding machines, but he ain't gonna fucking believe out. He doesn't. You only have to press the fucking out of phase button and you've got it there. Put them out of phase, it's gone. It nulls out. It doesn't understand. Unless I'm misunderstanding what he's saying, but he does seem to keep emphasising the same frequency laid on top of one out of phase makes double the frequency. No, it doesn't, you cretin. You know what I mean? It just doesn't. You see, he might be thinking, because I did that in my kitchen on that other unit down there. I can't fucking... Right, see, it's on the floor down there. Oh, where is it? Yeah! My camera lead doesn't work anymore. My extension lead, so I can't really move anything now. Oh, where's it gone? Oh, anyway, this camera won't go down low enough. Oh, there. Yeah. That box on the floor. Remember when I was using that? I was feeding the voltage from the amplifier into bridge rectifier. Now, maybe he doesn't know what a bridge rectifier is. I don't like to sink his horse, but you know what I mean. It's not that daft. But bridge rectifier, full wave rectifier. Maybe he's got the idea in his head, because I'm feeding say 50 hertz into that, and we get out a 100 hertz. That's doubling the frequency because of his laying 2 out of phase on each other. But he's missing the point of how that sodding works. That the frequency is doubling because you're chopping off the lower half of the cycle, and it's been kind of effectively, to all intents and purposes, flipped up. So you end up with twice as many positive going next halves of the cycle, but no 0 going halves. But in his example, when he keeps saying that 2 sine waves over the top of one, or 2 waves over the top of one another with the exact same frequency, out of phase, make double the... No, he fucking doesn't. How does he think? Oh, he's got a right weird way of looking at things. He needs to study harmonics a little bit. Harmonics is a bit complicated at first, but you soon get into it, and it is actually interesting, but not doing it his way, where you just, I thought of this, it must be right. Yeah, that isn't how it works. You have to fucking test these things out and say, oh no, it isn't right. That's the whole point of doing experiments, to prove yourself wrong now and then. If you never prove yourself wrong, then you never prove anything, because, yeah, unless you're a born genius, which he probably thinks he is. You can't be right all the time, but I suppose he thinks he is right all the time. Although I've heard him admit now and then he's wrong. So that's the puzzling thing I don't quite get, because sometimes he does have a little bit of humility, but it is fucking a rare instance. It's get your cameras out time, and it fucking take a photograph of Gary saying, "Oh, I was wrong there." Doesn't happen very much. Doesn't happen very often, does it? I say I'm wrong a lot, because I am wrong a lot. But he's wrong a lot, but he doesn't admit it. He sticks his guns. There's no current in Lenz's law. No, there's no current in Lenz's law. That's the only fucking thing he's about, you daft cunt. Oh. See, I wouldn't be mocking, except that, you know why. Well, I hope you know why. Gary, if you're listening, I'm sure you are, because you nosy twat me. I don't appreciate that your insulting comments about my experiments done at your behest for fucking nothing, when you weren't willing to pay a fucking dime to do anything yourself. I was doing it for myself anyway, but not your version. Just wasn't. I thought, well, while I'm doing my own tests, might as well do yours. Well, mine have been proved wrong. I don't mind admitting mine went wrong. Why are you different when my experiments proved myself wrong? Why are you any fucking different when yours are proved wrong? What crap experiments. No, they're not crap, man. It's your crap fucking theory. It's not even a theory, it's a hypothesis. You need to learn the difference. It's a guess. That's all we're all doing, we're just guessing. Humility is a good thing. Have a bit. Anyway, that'll do for now.